Hello everyone, welcome to my channel proChem Academy. Now in this video I will discuss about the second portion of study of gas laws. Now in last video I have discussed about the Boyle's law and its mathematical equation I have discussed. Now from there I will start where I have finished. So today I will start from the graphical representation of the Boyle's law. Okay, now let me clear you again another thing that Boyle's law, what I told last day, that it defines when temperature is constant, the volume of a gas in inversely proportional to pressure. That means temperature equal constant. It was the Boyle's law, and from here we have got PV equal K. PV equal K. Now from here we can easily see that if you increase the volume, then pressure of the gas will decrease. That means inversely proportional, and if you decrease the volume, then pressure will increase. Now if one want to plot the volume versus pressure of ideal gas, okay, then what kind of graph we will get? So graph of, or plot of, you can say plot of V versus P for ideal gas. Now what we can do, we can place along y-axis volume and along x-axis pressure. Okay, V versus P. So we will get a curve like this, which shows a hyperbola. So the curve is nothing but nature is hyperbolic curve. Nature hyperbolic curve. Now here we can easily see, here the volume in this region, the volume is highest, but here in this point the pressure is lowest. So when volume is highest, pressure is lowest. Again, volume is slightly decreased, pressure slightly increased. Volume slightly decreased, pressure slightly increased. So this is the plot of V versus P, and this is very important. Okay, this is the plot of V versus P from Boyle's law. Okay, done. Now we will do another plot. That means PV versus, that means pressure volume work versus pressure. Okay, pressure volume work versus pressure. Now let me see how it will be look like. Again, we can write here plot of PV versus P. So along y-axis we are plotting PV, and along x-axis we are plotting P. This is the origin. Okay. So as there is no inversely proportional relation between PV and P, so we will get a curve which will be parallel to the pressure axis. Okay. Parallel to the pressure axis. There is no change, sudden change in the pressure volume work versus pressure. So parallel to pressure axis. Nature will be parallel to pressure axis. Okay, these two curves are very important from Boyle's law. Okay, for class 9. This is for only class 9 book, ICSE. Okay, and again for the beginners of class 11, they can also see this video. Okay, now we are going to plot an extra plot. That means we are going to plot log P versus log V. Okay, that is very important. If you have not read a log function, then I am telling you, log is the function when we cannot get the value of a square root. That time log function we can include in that. Okay, so I am just using this one. So P versus V we have done. PV versus P also done. Now plot of log P versus log V. Okay, now let me see how it is coming. Okay, let me show you. We know PV equal K. Okay, now log is a function we can take in both sides. Log function can be taken in both sides. Okay, or ln can be taken in both sides. Now ln means log to the base e. ln means log to the base e, and log to the base 10 means, or we can convert log to the base e to the log to the base 10 by multiplying 2.303. Okay, by multiplying 2.303. So first of all, we are taking both sides ln. Ln means in chemistry or physics, ln means log e to the base e, log to the base e. Okay, now we are taking both sides log pv, here also log means to the base e. Okay, that means ln. Okay, now let me clear you one formula of log to the base e xy. Log to the base e x into y, that means it is log x plus log y. Very easy. If any product, that means multiplication, is there under log, it will be sum, that means log x plus log y. X and y are multiplied, so it will be log x plus log y. Okay, so here also we can do log to the base e p and log v to the base e. Okay, and it is also log k to the base e. Now this log can be transferred to the base e, to the base 10. Log to the base 10 we can do. It can be transferred to the log to the base 10. Okay, or we can take log e also, no problem. So here what we want to do, we want to place log p at the y axis, okay, minus log v at the x axis plus log k to the base e. Okay, log k to the base e. Now this relation can be compared with straight line equation. Can be compared with a straight line equation. Now we know a straight line equation is like this. Straight line equation. Straight line equation is what? Y equal mx plus c. This is the straight line equation. And if any, this is the normal algebraic form of straight line. Y equal mx plus c. Okay, and geometrical form or graphical form will be, if it is y and it is x and it is 0, 0 origin, then we will get, if it is c is there, c means intercept, we will get a curve like this. Okay, where the difference between here to here, it will be c, that means intercept. C is nothing but intercept. Okay, C is nothing but intercept. And if we draw a tangent on here, and if this angle is theta, then slope equal to m. This is nothing but the slope, and C is intercept. The curve will be look like this. Any kind of equation which can be compared with y equal mx plus c, that will be like this. That will be like this. The graphical representation will be like this. But here we can see one negative sign is here. That means here, after comparison, in y-axis it will be log p to the base e. In the place of c, log k to the base e is here, and instead of x, log v to the base e is here. But instead of m, it is minus 1. That means here the slope is negative. Slope is negative. Now if the slope is negative, the curve will not be look like this. This is for positive slope. This is for positive slope. So we'll get a curve like this for negative slope. Okay, I'm just erasing this one. So for negative slope, it will be log p, log v. Okay, the curve will be look like this. Okay, look like this. Now m is minus 1. That means slope is minus 1. Slope is minus 1. Why the curve is look like this one, not like that? Okay, slope is minus 1. Now slope can be determined by the formula tan theta. That means slope is equal to tan theta. This one we have to keep in mind. Slope is equal to tan theta. Now tan theta equal minus 1. Okay, now the what angle of tan gives minus 1, that is tan 135 degree. Tan 135 degree. So theta equal 135 degree. So here the angle should be 135 degree. That's why the curve is look like this. So the nature of the log p versus log p curve is A straight line with negative slope is a straight line with negative slope. Okay, done. So we have done the normal discussion of under Boyle's law. Okay, after that we will discuss some after finishing of Charles' law, we will discuss the numericals problem. Okay, now we go into the Charles' law. Now what is Charles' law? We have seen that in Boyle's law, temperature is constant but volume is inversely proportional to the pressure. Temperature is constant but volume is inversely proportional to pressure. But Charles given one relation where, okay, given one relation where pressure is constant, pressure in Charles' law, pressure will be constant and same mass of an enclosed gas is fixed. Mass is n and pressure is v. So pressure is constant and mass of an enclosed gas is fixed. In that case, what are the variables? Variables are v and t. Okay, variables are v and t. Now, as temperature we can calculate in both scale, that means Celsius scale and Kelvin scale. So Charles' law can be defined according to Kelvin scale also, according to Celsius scale also. Okay, so first Charles defined the law according to the Celsius scale. Okay, Celsius scale. Normally, just I am telling, we will see the relation between volume and temperature. Okay, and it will be seen that these are tightly proportional. Volume proportional to temperature. Now, this temperature is in Kelvin, not in Celsius. Okay, so we'll start from the Celsius scale. Okay, now what is the statement? What is the statement? It can be done. It can be written by any one of the ways. It is written in your book. You will see. Okay, in any kind of standard book, it will be written. Now, volume of an enclosed gas with fixed mass. Volume of an enclosed gas with fixed mass, okay, will increase by 1 by 273 part of the volume, okay, by 1 by 273 part of the volume at 0 degree centigrade temperature with every 1 degree centigrade rise in temperature or increase in temperature, and vice versa, if pressure of an enclosed gas is constant. The statement is it will be 4 or 5 line, you can see, but we have to understand first properly the statement, what the scientist Charles want to say. That time, after that we can write this statement. Okay, so it is telling the volume of an enclosed gas with the mass fixed with fixed mass will increase by 1 by 273 part of the volume at 0 degree centigrade temperature. That means volume will increase from the volume at 0 degree centigrade temperature if we increase the temperature by 1 degree centigrade. That means every 1 degree centigrade temperature increased. If we increase the temperature by 1 degree centigrade, then volume will increase 1 by 273 part of the initial volume or part of the 0 degree centigrade volume. Okay, and vice versa. That means if you decrease the temperature by 1 degree centigrade, every 1 degree centigrade, then volume will decrease by 1 by 273 part if pressure is constant. Okay, now let me show you mathematical. Okay, let us consider every the volume of a gas will not be 0. Okay, volume of a gas will not be 0. So at 0 degree centigrade temperature, the gas will have a volume. We'll see afterwards. Okay, let at 0 degree centigrade temperature, 0 degree centigrade temperature, the volume of gas is V0 or V0, you can say. Why 0? I have written V0 because at 0 degree centigrade. Okay, now with increase of 1 degree centigrade temperature, volume increased. According to Charles' law, if you increase the temperature 1 degree centigrade, then volume will increase. Now, how much part will increase? It will increase by 1 by 273 part of the initial volume. That means the volume at 0 degree centigrade is V0. Volume at 0 degree centigrade is V0. Okay. Now 1 by 273 part increased. That means V0 into 1 by 273 part, this part increased. Okay, this part is increased. Volume increase, with increase of 1 degree centigrade temperature, volume increased. This part increased. Okay, now then at 1 degree centigrade temperature, volume becomes at 1 degree centigrade temperature, the volume can be written as V1. It can be shown by V1. So what becomes? Say I have 2 rupees. Okay, someone has given me another 3 rupees. Now I have 5 rupees. That means the volume of the gas was V0. Now volume increased this part. Now the volume become this one. This is called V1. Okay. Again, as same wise, at 2 degree centigrade temperature, the volume becomes V2. It will be increased by 2 by 273. For 1 degree centigrade temperature, it increased by 1 by 273. By 2 degree centigrade temperature, it will increase by 2 by 273. Okay. So V2 equal V0 plus V0 into 2 by 273. Okay, likewise, if anyone increase the temperature T degree centigrade, then it will be Vt. Instead of 2, 1, I am writing T. V0 plus V0 into 1, 2, dot T. Increased by T. Vt equal V0 plus V0 into T by 273. Now I think it is clear that with every 1 degree centigrade rise in temperature, the volume of a gas will increase by 1 by 273 part of the initial volume, part of the volume at 0 degree centigrade. If pressure is constant. Okay, pressure is constant. Okay. Now this relation Vt, we can take V0 common, V0 common can be taken. So here 1 plus T by 273. 1 plus T by 273. Okay. Now this is the mathematical relation of Charles' law. Mathematical relation of Charles' law in degree C. That means in Celsius, where T is the temperature in Celsius. Okay, if you increase the temperature by increasing temperature in temperature, if you decrease the temperature by 1 degree centigrade, then volume will decrease again by 1 by 273 part. So by decrease in temperature, it will be minus Vt. Okay, V0 1, instead of plus T we have to write minus T. So this formula will be applicable if you decrease the temperature. Now combining, we can say, combining these two, we can say that Vt V0 1 plus minus T by 273, plus for increased temperature and minus for decreasing temperature, V plus minus T. Okay, so this is the relation of Charles' law at centigrade, in centigrade. Now by taking into consideration only that if we are increasing temperature, not decreasing, we can arrive in the Charles law according to Kelvin scale. Now how we can arrive? Okay, let us see how we can arrive in the Kelvin scale. Okay, now here Vt, so in Kelvin scale, okay, we are going into Kelvin scale. Vt, V0 1 plus T by 273. Okay, now what we can do? Okay, just take the LCM of 273. 273 LCM, so 273 into 1, that means 273 plus T. Okay, now we know that Kelvin scale is related to the Celsius scale by this formula. That means the temperature is in Kelvin scale is capital T, and in Celsius scale small t plus 273. This is the relation. Now instead of this 273 plus small t, we can write capital T. We can write capital T. Okay. Now we know for a particular gas, it is transferred in Kelvin. T is in Kelvin. For a particular gas, the initial volume is constant. That means we are not changing the initial volume. Initial volume will be same at 0 degree centigrade. So V0 is constant and 273 is number, it is also constant. So if we replace this equal sign or V0 by 273 as K, we can replace K here equal to V0 by 273, which should not be 0 and equal constant. Now we can replace this equal and K by, this should not be right as T, small t, by a proportional sign to capital T. Now from here we can easily say that in Kelvin scale at constant pressure of an enclosed gas with fixed mass, the volume is directly proportional to the temperature. Volume is directly proportional to the temperature in Kelvin scale. Volume is directly proportional to temperature in Kelvin scale. Volume is directly proportional to temperature in Kelvin scale, okay, at constant pressure and fixed mass. Okay, so this is the relation of Charles law at constant pressure in Kelvin scale. Okay, now at constant pressure, the volume of a gas in Kelvin scale V1 and temperature T1, and it is transferred to another state where volume is V2, temperature is T2. Now according to Charles law, for this enclosed gas, it will be just take this equation, V1 equal KT1, and for here V2 equal KT2. Okay, now you want to compare the different states, then what we can do, we can divide V1 by V2, 1 divided by 2. V1 by V2 equal KT1 by KT2. So you can write V1 by V2 equal T1 by T2. Now from this relation, if we know any three of the variable, any three of these four variable at constant pressure, then we can easily calculate the another one, last one. Okay, so this relation is applicable to some of the numerical problem. Okay, we can do the numerical problem according to this equation, that is Charles law, and if the pressure is constant. So Charles law will be only applicable if the question asks like the pressure is constant, then we will apply the Charles law. Okay, okay. Now from here we can plot a curve for Charles law. Okay, for V versus T, we have seen V equal KT, V equal what? KT. So if plot of volume versus T in Kelvin, obviously in Kelvin, then we can compare this one as y equal mx plus c, and it will be a straight line from the origin, because there is no intercept, so it is y axis, it is x axis. Now here it is volume, here it is temperature in Kelvin. So V versus capital T plot is nature is straight line from origin. Okay, straight line from origin. So plot of V versus T. Then again we can plot the V versus small t, that means in Celsius. Both curves are coming actually in board exam also, ICSE board exam, and also it can be taken into the higher classes also. Okay, so this is very important. So for Celsius scale, we have to start from the equation in Celsius. V equals 1 into T plus 2 by 273. This was the equation of Charles' law. Okay, for Charles' law in Celsius. Now what we can do? We can rewrite this equation like this, multiplied. Okay. Now we want to plot this. Here V0 will be there. V0, V0. Okay. So this equation can be compared with y equal mx plus c. How? V0 by 273 into T plus V0. Now this is nothing but y. This is m. This is x plus c. This one is t. Okay, so we can plot a curve. We'll get a plot like this. Okay, just I'm plotting the curve. Along x axis small t, along y axis this V, capital V. Okay, V. So we'll get a curve like this with a slope is V0 by 273 and intercept is V0. Okay. Now this Charles law curve V versus small t can be extrapolated to negative axis, and if we extrapolate this curve into negative axis, this will cut here at 273 degree centigrade. Actually 273.15 degree centigrade. So we'll see that this minus 273 degree centigrade temperature has a significance. That we will see from Charles' law that this point minus 273 degree centigrade has a significance which is called absolute temperature. That in this temperature the volume of gas molecule becomes zero. Okay, at absolute temperature, that means minus 273.15 degree centigrade, the volume of gas molecules become zero. Okay, or before the volume of the gas molecule becomes zero, we cannot achieve this temperature. So what is absolute temperature? The temperature in which volume of gas molecule becomes zero, that is called absolute temperature. Okay, so the calculation of absolute temperature we will discuss in next video. Okay, so up to this absolute temperature. So if you like this video, then do like and complete this chapter. Up to this you complete and practice in your home, and just see complete video. Okay, so thank you everyone.